Okay, now let's do another problem. Find the inverse Laplace transform of x of s is equal to s plus 3 by s square plus 10s plus 41. Okay, so here in this problem I'm not going to factorize this using complex poles. Okay, let us do this method by applying the as plus b format. Okay, so here how do I solve this without factorizing this into complex poles? How can I solve this without factorizing this into complex poles? Okay, so let's do this problem. Given x of s is equal to s plus 3 by s square plus 10s plus 41. Okay, so now how should I factorize this denominator? Okay, just like in the previous problems, the perfect way to factorize this is by looking at the first two terms. Okay, just simply look at the first two terms. So here the first two terms are s square and 10s. Okay, so what will happen if I add s square plus 10s? What is s square plus 10s? If I write s square, you know this 10s can also be written as s square plus 2 into 5 into s, right? This can also be written as s square into 2 into 5 into s. We know that it is a square plus 2ab plus b square is equal to a plus b the whole square. So if I want to factorize this, I'm going to factorize this using the first two terms, and this first two terms I can express like this, and then all I need to do is if I simply add 5 square along with this, then this will be nothing but s plus 5 the whole square. Okay, this is how I factorize it. Okay, so how would I factorize is that I take, just like the previous videos, I take the first two terms, okay, and then I try to complete this equation to make it a factorizable. So I know that if I add 25 along with it, if I add 5 square along with it, then this equation will be nothing but a plus b the whole square, right? So I made this in that format, so it will become s plus 5 the whole square. Okay, so in that case I will get over here, this can also be written as s plus 3 by s square plus 10s plus 25. So 41 minus 25 is 16, right? 16 plus 16. This is how we get. Okay, so now this is nothing, first three terms is nothing but s plus 5 the whole square. So this can be written as s plus 3 by s plus 5 the whole square plus this 16 is nothing but 4 square. You see, this is how we factorize it. Okay, so now what I usually ask you all to do is, while factorizing this, we have to make this into a format of as plus b, right? As plus b. But here you need not find the value of a and b over here, because here already the format is given as such. If you can see here, the value of a is 1 and the value of b is 3. So you don't have to again find the value of a and b. You see, it's already given. The value of a and b is already given. So all you need to do is to learn to factorize the denominator and then find the answer. Okay, so now what will I do after this? Okay, so when I make this into a form, in this kind of a format, all questions you'll be able to make in this kind of format, and then what you have to do is we have to apply our basic formulas. That is, we know that the Laplace transform of e raised to minus 80 cos ohm 0 t u of t, unilateral Laplace transform, is equal to, we know it is nothing but s plus a by s plus a the whole square plus ohm 0 square. Okay, and also the Laplace transform of e raised to minus 80 sine ohm 0 t u of t is equal to, it will be the other term, that will be ohm 0 by s plus a the whole square plus ohm 0 square. Okay, so now what you need to do is you need to look at this and look at this. and then you have to look at this and then look at this and see how you can make this format into this format and this format. Okay, here look very carefully. If you are going to apply this formula, you have to make sure that the denominator must be s plus a the whole square plus ohm 0 square, and that I have already done. See, this is s plus a the whole square plus ohm 0 square. Okay, so I have already made the denominator to this part. Now I need to make the numerator. Once when I finish making the numerator, then I can now simply apply the formulas and find the inverse. So now if you look over here, the denominator is in this format, right? So look at the numerator. The numerator must be s plus a. That means the numerator must be this very same term over here, s plus a the whole square. So that s plus a should be written in the numerator. So here if you can see, here on the first term is s plus 5 the whole square. So that means you need to create an s plus 5 in the numerator. Also, now for this format, if you want to make this into this format, what is required is that you need, in the numerator side, you need an ohm 0. You need the second term, the constant, ohm 0 square. So here ohm 0 is 4, so you need to put a 4 inside this. So what you require is basically you need a s plus 5 and you need a 4. Okay, so now if you look at this, what is written over here is s plus 3 is written over here, right? So I need to make this s plus 3 into s plus 5, right? So that means I can write this in this format. X of s is equal to s plus 5 minus 2, which is nothing but 3, right? This 5 minus 2 is 3. So I have written this in this format. Why? Because I want to create s plus 5 in my numerator so that I can have s plus a in the numerator. So this has become s plus 5 the whole square plus 4 square. Okay. Now this can also be written as s plus 5 by s plus 5 the whole square plus 4 the whole square minus 2 into, this can be written as 1 by s plus 5 the whole square plus 4 the whole square. Okay, this is how we do it. Okay, so now look, this is the good news. The first term I have already made it in this format, right? This is nothing but s plus a by s plus a the whole square plus ohm 0 square. Alright, so I have already found the value of this. Now I need to find the value of this. How can I find the value of this? You can see only thing is over here is a constant, and here the constant what I need is ohm 0, right? That means the second term, ohm 0. Here the ohm 0 is 4. So what I'm going to do is I'm going to divide and multiply my second term with 4. That's all. Very easy. So this will become s plus 5 by s plus 5 the whole square plus 4 square minus 2, divide this by 4 and then multiply that same 4 over here. You will get this format, s plus 5 the whole square plus 4 square. Okay, so now this format is basically s plus a by s plus a the whole square plus ohm 0 square, and this is nothing but minus 1 by 2, right? 2 by 4 is 1 by 2, minus 1 by 2 into, this is nothing but ohm 0 by s plus a the whole square plus ohm 0 square. Now I can simply apply my Laplace inverse, right? So that means I can say that x of t is equal to the Laplace inverse of s plus 5 by s plus 5 the whole square plus 4 square, right, minus 1 by 2 into Laplace inverse of 4 by s plus 5 the whole square plus 4 the whole square. Okay, this is nothing but e raised to minus 5t cos cos 40 u of t minus 1 by 2 into, this is nothing but e raised to here also minus 5t. This is Ohm's 0 by s plus a the whole square. So this will be sine 40 u of t. Okay, so this is your answer. Okay, this is how we solve the problem. Right, so now let's do the next problem. Let's do this next problem. Okay, so now if you want, you can now pause this video and write this question and try to solve this by yourselves. It will be a good learning method. Okay, here also, so what is the advantage of using this method? If this kind of question is asked, just remember that here it is only the degree of the coefficient. Here the degree of s is 1 and here the degree of s is 2. So which means already the value of a and b is already given. So in that case, it is better that you write it in this format and try to solve the problem. It is better that you don't apply the complex poles for these kind of problems. Okay. Usually one applies complex poles if you are finding it very difficult to factorize the denominator, but factorizing the denominator will not be that much difficult once you have learned the technique. The technique is just find any two and just find the third term that will be added along with the first two terms so that it will be made into a factorizable equation, and then you put the factorizable equation plus whatever the remaining thing square. Always this is how we can do. We can do any problem, any problem in which the denominator is not directly be factorizable. In that kind of problem, we can apply this kind of a step, right? That is, using the first two terms, try to make an equation, use that equation over here, plus whatever the remaining term over here, it be root of that square. Then you apply these two equations. Which one is relevant according to your problem, and then you make this, and then you have to make sure that the numerator must be same for in one case, and in the other case the constant in the numerator must be a constant. Okay, and then you solve the problem. Let's do the same thing or technique over here also. Okay, here find the inverse Laplace transform of x of s is equal to 2s minus 1 by s square plus 4s plus 8. So here also you need not find the value of the coefficient, because here as plus b is already given, right? The value of a is 2 and the value of b is minus 1. So all you need to do is simply factorize this and then find the inverse. Okay, so given x of s is equal to 2s minus 1 by, so how will I factorize this? Here the first two terms are s square plus 4s. So let me just do my rough work. S square plus 4s. Okay, so what should I add along with this so that this becomes a factorizable equation, right? So this is 2 into 2s, right? So that means if I add a 4 over here, then this is nothing but s plus 2 the whole square, right? This is s square plus 2 into 2s plus 2 square, right? So this is nothing but s plus 2 the whole square, or in other words, I can write the denominator in the form of s square plus 4s plus 4 plus 4. 4 plus 4 is 8. So I divide this 8 into 4 plus 4. And this 4 I can give it over here. The other 4 I can take it as the constant. Or in other words, I can write this as 2s minus 1 by, this can be written as s plus 2 the whole square plus 4 is nothing but 2 square. See, so here also I have made this successfully. I have made the denominator in this format, s plus 8 the whole square plus Ohm's 0 square, right? So we know that the Laplace transform of e raised to minus 8t cos Ohm's 0 t u of t is equal to s plus a by s plus a the whole square plus Ohm's 0 square. and the Laplace transform of e raised to minus 80 sine ohm 0 t u of t is equal to s, it will be ohm 0, ohm 0 by s plus a the whole square plus ohm 0 square. Okay. So one more thing also you need to understand is, suppose if instead of plus over here, if it is minus, suppose if instead of plus over here, when you do the problem, suppose you get a minus over here. If you get minus, then you know what the equation is. It will be Laplace transform of e raised to minus 80 cos h, right? Hyperbolic cosine transform. Cos h ohm 0 t u of t is nothing but s plus a by s plus the whole square minus ohm 0 square. Like, and same way, if it is a minus over here, then here also it will be Laplace transform of e raised to minus 80 sine h ohm 0 t u of t, hyperbolic sine function, is equal to ohm 0 by s plus a the whole square minus ohm 0 square. Okay, so here it is plus, so these are the two equations you are going to need for this answer. Okay, so here now what I'm going to do is I'm trying to make this numerator in this format. That means I need in the numerator, I need s plus a. Here s plus a is s plus 2, so I need an s plus 2 somewhere in this equation. Here what you have, if you inspect carefully, here there is already an 2s, not s, here it is 2s. So I need to convert this s over here with s plus 2, right? I need to convert this s into s plus 2. Okay, so how will I do it? I can write that x of s is equal to, I can write this numerator in this 2 into s plus 2. So what is being added? 4 is being added, right? 2s plus 4. So 4 is being added. So I'm going to minus 4 to equate it. Minus 1 by s plus 2 the whole square minus 2 the whole square. See, this is how I do it. This is nothing but 2 into s plus 2 minus 5 by s plus 2 the whole square minus 2 the whole square. Or in other words, this can also be written as 2 into, so I can now separate this into two terms. So the first term, it will be 2 into, this is nothing but s plus a by s plus a the whole square minus ohm 0 square, plus ohm 0, sorry, it's plus over here, plus. Okay, see, s plus 2 by s plus 2 whole square plus 2 square. So I have made this in this format. So now I can write the answer directly. And what about the second term? Here it is written minus 5. Okay, and what do I need at the numerator? At the numerator I need ohm 0, and ohm 0 here is 2. The ohm 0 here is 2. So I'm going to divide and multiply by 2. So I will get minus 5 by 2 into 2 by, which is, this 2 is ohm 0. So ohm 0 by s plus a the whole square plus ohm 0 square, right? So this is this and this is this. Okay, so that means I can say that x of t, I can write my answer as x of t is nothing but 2 into the Laplace inverse of s plus 2 by s plus 2 the whole square plus 2 the whole square, okay, minus 5 by 2 into Laplace inverse of 2 by s plus 2 the whole square plus 2 the whole square. Okay, or in other words, x of t is nothing but 2 into, this is here s plus a, so it will be e raised to minus 2t, e raised to minus 80, so e raised to minus 2t cos, ohm 0 is 2, cos 2t u of t minus 5 by 2, here it will be sine, so e raised to minus 2t sine 2t into u of t. So this is your final answer. Okay, if you are applying complex poles, so what you're going to do is this will become s plus 2 plus 2j into s plus 2 minus 2j. That's how the numerator will become, the denominator will become. And then you are going to factorize this into two separate factors. Then you're going to find the value of a and b and then do this problem. Okay. Here also you will get the answer quickly, but you are going to spend a lot of time in making the answer in this format. That's what one of the disadvantage of using complex poles. Okay, so all you need to do is simply remember these two equations. Then in that case, then you can convert any equation at the denominator which you cannot factorize into a factorizable equation by simply applying this technique. Okay, so this is how we do the problem.